Hello everyone. In this lecture we will discuss on vapor compression refrigeration system. So this is a type of refrigeration cycle which is used for the purpose of domestic refrigeration. So the basic components of this vapor compression refrigeration system or VCRS are evaporator, compressor, condenser, expansion valve. The expansion valve is otherwise known as throttling valve. So for this VCRS, here we draw the coordinate diagram, that is TS and PH diagram, and the basic functions which takes place in this VCRS are reversible adiabatic compression process, that is for compressor, constant pressure heat rejection process for condenser, isenthalpic expansion process, that is for expansion valve, and constant pressure heat absorption process, that is for evaporator. So see, here we draw the TS and PH diagram. So the 1 to 2 process is for compression process. So this is for TS diagram, and here we draw this for PH diagram. So for TS diagram, here the 1 to 2 process is considered to be a straight vertical line, but for PH diagram this is a curved line. So this indicates what? For adiabatic compression process, the entropy is constant but the enthalpy is increasing, right? Next is 2 to 3 process, that is constant pressure heat rejection process. So during this 2 to 3 process, the heat rejection takes place. Next is 3 to 4 process, that is for expansion valve, or you can say that is for throttling valve. This is expansion valve, or that is a throttling valve. So during this process, what happens? The enthalpy remains constant. So this enthalpy remains constant, that is clearly visible on this pH diagram. So 4 to 1 is constant pressure heat absorption process. So that is for evaporator, that is 4 to 1 process. So now we consider the function of a compressor. So in compressor, the low pressure and temperature vapor refrigerant from evaporator is drawn into the compressor through the inlet and suction valve, where it is compressed to a high pressure and temperature. The high pressure and temperature vapor refrigerant is discharged into the condenser through the delivery or the discharge valve. So next, after the high pressure and high temperature reach to the condenser, so what happens in the condenser? The condenser consists of coils or pipe, because this condenser is a kind of heat exchanger in which high pressure and temperature vapor refrigerant is cooled and condensed. The refrigerant, while passing through the condenser, gives up its latent heat to the surrounding, that is Q1, condensing latent heat to the surrounding condensing medium, which is normally air or water. So next one is expansion valve. Now what happens to this expansion valve? This expansion valve is also known as throttle valve, which already we discussed. So, or this throttle valve is also known as refrigerant control valve. The function of the expansion valve is to allow the liquid refrigerant under high pressure and temperature to pass at a controlled rate after reducing its pressure and temperature. Some of the liquid refrigerant evaporate as it passes through the expansion valve, but the larger portion is vaporized in the evaporator at the low pressure and temperature. So next one is evaporator. Now the vapor refrigerant which is converted to liquid in the condenser that will pass through the expansion valve and reach to the evaporator. So an evaporator consists of coils or pipes, because this is also a kind of heat exchanger in which the liquid vapor refrigerant at low pressure and temperature is evaporated and changed into vapor refrigerant at low pressure and temperature. In evaporation or in evaporating process, the liquid vapor refrigerant absorbs its latent heat of vaporization from the medium which is to be cooled. Right? So for this vapor compression refrigeration system, if we measure the performance, so how we can measure the performance? So that is measured by the coefficient of performance, that is COP. So here COP is equal to refrigerating effect by work done. So that is in simple way the desired effect by net work done. So desired effect is what? We have to absorb the energy, that is heat energy, from this space, that is Q2. So here it is Q2, and work done, so that is considered for the work done during the compressor, that is compression process. So that is WC. So here if we define this heat energy and work in terms of change in enthalpies, so Q2 equal to H1 minus H4. So this is the Q2, this is the evaporation process, 4 to 1. During 4 to 1 process the evaporation takes place. So during this, what is the change in enthalpy? That is H1 minus H4. That is H1 minus H4. And WC, that is the compression process. So during this process, what is the change in enthalpy? That is H2 minus H1. So if we consider the value of H1, H4, H2, so we can get the performance or the coefficient of performance of the VCRS system. So next we define the ton of refrigeration. A ton of refrigeration is defined as the amount of refrigeration effect produced by the uniform melting of 1 ton, that is 1000 kg of ice from and at 0 degrees Celsius in 24 hours. So 1 TR equal to 1000 into 335 kilojoules. So this is the latent heat of fusion for the ice is equal to 1000 into 335 divided by 24 into 60. So this is for 24 hours. So 24 hour. So we convert this into per minute. So 60. 1 hour equal to 60 minutes. So this is this is equal to 232.6 kilojoule per minute. But approximately the value is used everywhere, that is 1 TR is approximately equal to 210 kilojoule per minute, or that is 3.5 kilowatt. So this is about the ton of refrigeration and coefficient of performance. So see, this is the TH diagram and pH diagram, where we consider during the compression process. So as the vapor is compressed, liquid vapor, that is the vapor refrigerant, is compressed in the compression process. So at the end of the compression process, we consider to be, that is saturated state. So this saturation, due to this is considered as, this is the saturated state, but the initial state of the compressor is wet. So this is considered to be the wet compression process. If the state of the liquid refrigerant is saturated at the beginning of the compression process, it means the state 1 lies here, then we can say that is the case of a dry compression process. And dry compression is always preferred to wet compression, because the wet compression, there is a danger of the liquid refrigerant being trapped in the head of the cylinder by the rising piston, which may damage the valves or the cylinder head, and the droplets of the liquid refrigerant may wash away the lubricating oil from the walls of the cylinder, thus increases the wear in the compressor. So that's why the dry compression is always preferred in comparison to the wet compression. So if we consider the case of a dry compression, it means the state 1 is considered to be here. If the state 1 is considered here. So the state 2, it will consider to be in, that is in this superheated region. But if we consider the wet compression, so it means the state 1 lies in the wet region or in the mixed region. So I think it is a clear idea about this VCRS system. So if you have any queries regarding this VCRS, you can ask in the comment section. Thank you for watching the video.